Okay, now let's move to the second type of op-amp, that is what we call non-inverting amplifier. What is non-inverting amplifier? So how you going to identify this is non-inverting? You check the input is connected to the positive. So your input signal here, AC sine wave, is connected to the positive non-inverting input. So that's why we call this one non-inverting amplifier. So please take note, the feedback resistance will always maintain at where? At the negative. So that's why in your op-amp, you will always recall negative feedback. Negative feedback. Why? Your feedback will not be changed because it will always connected to the negative to make it as an op-amp. Okay, now so let's try to derive the gain. So what is the gain? It's actually V out over V in. So first, golden rule, voltage rule. So when here is not 0 anymore, here become V in. So the voltage across here is V in. Using voltage rule, it will make both voltage at this node will be the same. So let's say here is V1. So the voltage at this node here also will be V1. Okay, so V1 will be equal to V2, that is V1. Okay, apply golden rule number 2, that is current rule. So where you're going to apply here, the current flowing to the op-amp will be always equal to 0. So there will be no current flowing inside the op-amp. Okay, now so let's apply KCL law. KCL. So what KCL mentioned here is I1. Let's say we denote here A. So this is the node A. Current leaving is actually I2, and another current leaving here is 0. So we can denote I1 equal to I2. What is I1? So apply Ohm's law. So here is 0, here is V1. So 0 minus, here is 0, here is V1. Okay. So 0 minus V1 divided by R1 equal to, so we go to I2. I2 means V1 and V0, right? So I2 equal V1 minus V0, the change of the voltage divided by the resistance. So we arrange this one until you got the gain V out over V1. So let's say I rearrange here, it becomes V1 over R2 minus V out over R2. So move your V out over here, then it becomes V1 over R1 plus 1 over R2. So you will keep continue here. So V out over V1 equal to R2 1 over R1 plus 1 over R2. So if you take note here, so it becomes R2 over R1 plus 1. So this is the gain AV of the non-inverting amplifier is 1 plus R2 over R1. So now the gain is derived. Okay, so you can see here for the non-inverting amplifier, you can get the gain 1 plus R2 over R1. Okay, so let's say in your non-inverting input, you apply here 1 volt. And your gain will be always positive here because it's non-inverting. Let's say multiplied by 2. So here you can get 2 volt. If you see the shape is not inverted. For inverting amplifier, your output will be inverted. But for non-inverting amplifier, this is your input. Your output will remain the same and inverted. Okay, so let's continue the third type of amplifier. That's what we call buffer. So what does that mean by buffer? You are going to use this buffer to isolate or separate one circuit from another. So the gain for the buffer is actually 1. So let's say your input here is 0, it will always be 0. If you apply input 1, it will be always 1. So why we need this buffer? To isolate or separate one circuit from each other. So how the circuit of buffer looks like? So it is generated from what type of amplifier here? So if how are you going to identify this is what type of amplifier? Is this inverting or non-inverting? We need to look at the V1. So you see V1 here is connected to the positive, the non-inverting input, right? So we can call this one non-inverting amplifier. So in order for you to change this non-inverting amplifier to a buffer, you need to make sure these two conditions. So means your R1 is infinite. So here is become infinite. Your R2 here will be 0. So what does it mean by R is 0? So it means that your R2 is very small. So you can assume it is negligible and it will become short circuit. So that's why you don't have any element at the feedback due to R2 is equal to 0. How about R1? R1 is very high, that is infinite. So means it become open circuit. So this one will be not connected. Okay, and then your input will maintain at the non-inverting. Your inverting will be directly connected to the Vout. So let's say I apply here 2 volt. Voltage rule number 1 says if this one 2 volt, the node here will also be 2 volt. So this 2 volt will bring towards to the feedback without any resistor, and you can get your Vout is 2 volt. So what is the gain here? 2 divided by 2, that is equal to 1. So again, why we need this buffer? To serve as this protective barrier to isolate or separate one circuit from another, to prevent the circuit from loading the first circuit with some noise or interference to avoid that. Okay, so let's see one example of a buffer. So here is a comparison of a circuit without a buffer and with a buffer. So this is a load that directly connected to the source, and there is another circuit that is connected to the source via a buffer. So what will be the difference between these two? Okay, first we are going to compare what is the value of V out here. So how are you going to calculate V out? You just use the voltage divider. So by using voltage divider, 5 divided by 5 times plus 5 multiplied by the voltage source. So you can get here 5 volt. Okay, how you can get the current? I out equal V over R, so means 5 divided by 5K, you can get 1 milliampere. So the voltage here is 5 volt, the current here is 1 milliampere. So let's see the circuit with a buffer, what will happen to the supply. So here is 10 volt, so here also will remain 10 volt. Voltage rule number 1 says it will make both voltage the same. So it says that 10, this will become 10 volt. So it will be goes to the feedback, and your V out will be also 10 volt. So V out will be directly 10 volt, and how will be the output current? 10 divided by 5K will be 2 milliampere. So what is the role of buffer here to avoid the loading effect? So if you want this 10 volt to maintain at the output, you better use buffer because your 10 volt will be not interrupted by the internal resistor here. Okay, compared to here, your Vout become half compared to the input, and your current also become lower. So there is the role of buffer to separate or isolate the circuit from each other to avoid interference.